Meet Willy Messerschmitt, staring at something that shouldn't exist. At least, not in 1943. A sleek aircraft sits on the factory line. No propeller, no cooling radiators. Just two strange pods slung beneath swept wings. Inside those pods are engines that could change the future of air combat, if they don't kill their pilots first. This is the Me-262, the world's first operational jet fighter, powered by Junkers Jumo 004 turbojets. But there's a truth Messerschmitt isn't telling. These engines have a fatal flaw. They're built to self-destruct. Not from enemy fire, not from a blunder in the design, but by necessity. Dr. Anselm Franz, the Austrian genius behind the 004, had to choose between perfection and reality. Engines that would last for years, or engines that could be built now. He chose existence over perfection. The result was both a marvel and a death trap. This is the story of the men who flew them, knowing the clock was ticking. The women who built them from scrap. The engineers who pushed physics to the breaking point. Yes, the Jumo 004 looked like it belonged to the year 2000, but it was made with the metals of 1800. It proved that human ingenuity could defy reality, at least for a little while. Captain James Howard was leading his P-51 squadron over Bavaria when he saw it. A silver blur, moving faster than anything he'd ever witnessed. No propeller, no visible engine, just a banshee scream ripping through the sky. "What the devil was that?" his wingman radioed. Howard didn't know how to answer. It was November 1944, and he had just seen Germany's most guarded secret, the Messerschmitt Me-262, driven by twin Junkers Jumo 004 turbojets. The German in that cockpit was probably Oberleutnant Georg Peter Eder, one of the few trained to fly this revolutionary machine. Eder wasn't celebrating his speed. He was praying his engines would hold together. Each Jumo 004 produced 1,980 pounds of thrust, enough to push the Me-262 540 miles per hour. That's 100 miles per hour faster than Howard's Mustang, and 90 miles per hour faster than a Spitfire. But Eder knew something Howard didn't. His engines were living on borrowed time. The official lifespan was 25 hours. Many failed after just 10. Some barely made it to 5. As Eder screamed past the American formation, he wasn't just outrunning the enemy, he was outrunning a countdown clock that could turn his miracle into a glider at any moment. For the engineers who built them, every successful flight was a win against physics, chemistry, and common sense. They'd done the impossible. The only question, how long could it last? In 1935, when inspiration struck, Hans von Ohain was sipping coffee in Göttingen. A propeller-driven aircraft clawed at the sky, its blades thrashing the air. There must be a better way, he thought. What if you removed the propeller entirely? What if you sucked in air, compressed it, ignited fuel inside it, and blasted the exhaust backward to push forward? His physics professor said it was impossible. Fellow students laughed. Von Ohain didn't care. He spent his life savings, 1,000 marks, on a crude prototype in a garage. It was ugly, dangerous, but when he lit it up, it worked. For 10 minutes, then it exploded, leaving him deaf for a week. But those 10 minutes changed aviation forever. Word reached aircraft maker Ernst Heinkel, who hired von Ohain instantly. Together, they built the world's first jet aircraft, the HE-178. It flew in August 1939. The German Air Ministry was impressed, but cautious. They ordered other companies to try their designs. That's when Dr. Anselm Franz stepped into history. Franz was 39, head of Junkers' supercharger division. He obsessed over precision. Building a production jet engine would be his ultimate challenge. He had no idea he'd be forced to build perfection out of scrap. Dr. Franz approached the Jumo 004 project like a Swiss watchmaker, crafting his finest piece. Every part had to be exact, every tolerance tight, every component chosen for maximum performance. The first version, the Jumo 004A, was a thing of beauty. It used high-grade nickel for heat resistance, cobalt for strength, and molybdenum for durability. On the test stand, it purred at full power for over 100 hours without complaint. His team believed they had created the perfect jet engine. Then came the meeting that shattered that dream. It was early 1943. Franz sat in a sterile conference room across from Luftwaffe procurement officers. "How many 004As can you build per month?" they asked. "With proper materials and trained workers." "Perhaps 50, Franz replied. "We need 500, minimum." Franz froze. That was impossible without those rare metals. The officer didn't blink. "The nickel you need is already allocated to submarine hulls. The cobalt is going into tank armor. The molybdenum is reserved for artillery." Franz leaned forward. "Then what do I use?" "Whatever you can find. Scrap steel, recycled aluminium, substitute alloys. Make it work." The words hit like a hammer. All the meticulous planning, all the perfection, gone. Franz left the meeting knowing he had to rebuild his masterpiece from the ground up, without the materials that made it great. The perfectionist was about to become an alchemist. The task seemed insane. Build a jet engine that could survive temperatures of 1,800 degrees Fahrenheit, with metals fit for kitchenware. The turbine blades were the biggest nightmare. They had to spin at nearly 9,000 revolutions per minute, while glowing white hot. Usually, you'd use exotic alloys, but Germany's stockpiles were gone. Dr. Klaus Hoffmann, Franz's metallurgist, became the magician in the shop. He experimented for months, producing 2 new alloys from what was available: chromadur, a chromium-manganese-iron mix, and tinadur, a titanium-nickel-chromium blend. Neither was ideal, but they could be produced in bulk. The rest of the engine was simplified. Casings were cast from magnesium instead of precision steel. Combustion chambers were mild steel, coated with aluminium to keep the heat at bay. And because many skilled machinists had gone to the front, the designs were made simple enough for semi-skilled workers to assemble. But the genius was in the details. Hoffmann invented hollow turbine blades that were cooled by compressed air bled from the compressor, a trick to keep the inferior metals from melting. Maria Weber, an engineer, developed welding techniques for joining dissimilar metals with basic equipment. Chief machinist Otto Brenner eliminated unnecessary precision steps. "If it fits together and doesn't fall apart," he'd say, "it's good enough." The result was a jet engine that behaved like fine machinery, but was built like farm equipment. Franz knew they wouldn't last long, but 20 hours of flight was better than a perfect engine that only existed on paper. Lieutenant Franz Schall was 26 when he saw the logbook for his Me-262. Left engine, 8 hours, 30 minutes. Right engine, 12 hours, 45 minutes. "How long do they last?" he asked his crew chief. Hauptfeldwebel Klaus Meyer had been working on aircraft engines since the last war, but he'd never seen anything like the Jumo 004. "Officially, 25 to 50 hours, Meyer said. "Realistically, 10 to 15? Some don't make it past 5. Schall felt his stomach tighten. Major overhaul didn't mean a tune-up. It meant replacing the entire engine. The problem was simple. The metals couldn't survive the heat and stress for long. Turbine blades cracked, bearings seized, fuel systems clogged or burst into flames, and when they failed violently. A turbine could shatter and fling white-hot shards through the fuselage. A bearing could lock solid and freeze the rotor in a heartbeat. A fuel leak could turn the engine into a torch. "The trick," Meyer said, "is to listen. Every vibration, every pitch changes. Your life depends on it." Schall learned to read the engine like a heartbeat. Oil pressure, exhaust temperature, RPMs, vibrations, any change was a warning. Pilots shared survival tips. Never slam the throttles forward. Never stay at full power for more than 25 minutes. Always keep enough fuel for more than one landing attempt. Even with perfect care, they were flying time bombs. Some pilots ignored the countdown. Schall couldn't. Every mission, he calculated how much life his engines had left. Every flight was a race against an invisible clock. Germany had the fastest fighter in the world, but couldn't keep it in the air long enough to matter.
Irmgard Müller
was 19 when she learned to weld jet engine components under the flickering light of a war-torn sky. By 1944, the Junkers factory in Dessau had changed. The veteran engineers were gone, sent to the front. Their replacements were teenagers, forced laborers, and women pulled from offices and farms. Irmgard's station was in the turbine assembly line, the most critical and dangerous part of the Jumo 004. Each turbine blade had to be perfectly balanced. One flaw could cause vibrations that tore an engine apart in minutes. Her supervisor, Meister Heinrich Koch, had built engines for 30 years. Now, he was teaching shop clerks and farm girls to work with tolerances measured in fractions of a millimeter. "The metal will tell you what it needs," he told them, "but you must listen." Irmgard learned to read metal like a language. The ring of a hammer blow told her the alloy's hardness. The vibration under a file told her about internal stresses. The glow of heated steel told her when it was ready to be shaped. The metals changed daily. One day, she was working with steel salvaged from wrecked tanks. The next, it was aluminium from shot-down bombers. Sometimes, the material was so poor that they had to coat or treat it before it was usable. Irmgard developed instincts that astonished even the engineers. She could spot a microscopic crack just by how light played along an edge. Her friends were scattered across the factory floor. Anna worked on the compressor sections. Martha assembled fuel systems. Gisela built the complex casings that wrapped the whole engine. They worked 12-hour shifts, sometimes longer as Allied bombers roared overhead. The ground shook when the distant bombs fell. The hardest part wasn't the fatigue, it was knowing that young men like Franz Schall would bet their lives on the welds in their hands. One imperfect seam could mean a fireball over enemy lines. Still, they kept working. Because in their minds, they weren't just building engines, they were building the future, even if it was assembled from the ruins of the present. Major Walter Novotny was one of Germany's greatest aces. 258 enemy aircraft had fallen to his guns. Yet the Me-262 made him uneasy. Not because it was hard to fly, it was the opposite. Smooth, powerful, responsive. It was the engines that scared him. The Jumo 004s could fail without warning. Before every mission, Novotny personally inspected his aircraft. He ran his hands along the nacelles, checking for leaks. He listened for faint rattles and odd pitches. His crew chief, Oberfeldwebel Gustav Richter, understood the ritual. "How are they today, Richter?" Novotny would ask. "Running, sir, that's all I can promise." Richter kept meticulous records. By late 1944, his notes showed catastrophic failures in 60% of the engines he'd maintained. The Me-262's pilot manual read more like a bomb disposal guide than a flight handbook. Never slam the throttles forward. Why? Compressor stall. Never run at full power for more than 25 minutes. The result? Turbine failure. Also, always keep fuel for more than one landing. The engines might fail when you most need them. Novotny had engine failures on nearly half of his Me-262 flights. Twice, both engines quit in thin air at 30,000 feet. He managed to glide to the airfield each time. Once, his starboard engine exploded, flinging jagged metal through the wing. Still, he flew, because when the engines worked, nothing in the sky could touch him. On November 8, 1944, Novotny took off in a Me-262 with engines already showing signs of wear. At 1,000 feet, the left engine shook violently. At 500, it seized. The Me-262 rolled and plunged into the ground. Walter Novotny, the man who had survived hundreds of dogfights, was killed by the machine he'd feared all along. He was just 23. May 1945. Captain Harold Watson stood on a captured German airfield, staring at the strange aircraft before him. The Me-262 looked like something from the future. "Gentlemen," he told his team, "this is the next chapter of aviation." They opened the engine nacelles and admiration turned to shock. The axial flow compressor design was decades ahead of Allied efforts. The combustion system was elegant, but the materials? Crude, turbine blades of low-grade alloy, welds rough and uneven. machining marks where precision should have been perfect. Colonel Donald Putt shook his head. It's like building a Stradivarius violin out of driftwood and wire. Captured Luftwaffe reports told the truth. Average engine life? 10 to 50 hours. Failure rate? 50% within 20 hours. In-flight failure rate? 15% of all combat sorties. My God, Watson muttered. They were flying aircraft more dangerous to themselves than to us. Allied engineers read pilot reports describing near-death experiences from engine failures. Yet the sorties continued. The courage required, Putt wrote later, is beyond comprehension. Every flight was a test flight. When British jet pioneer Frank Whittle examined the 004, his verdict was bittersweet. They proved that brilliant engineering can overcome any material limitation, but the price is human lives. By January 1945, Dr. France was winning his battle. The new 004D could last over 50 hours. New throttle controls saved pilots from mistakes. Better alloys extended life. Factories were producing 1,500 engines a month. But the war was collapsing around him. Bombers destroyed half his facilities. His engineers were drafted to fight. Rail lines were shattered. Engines couldn't reach the front. Worse, there weren't enough trained pilots left to fly them. In February, France got the order. Stop development. Just build what you have. He knew that meant the 004 would stay trapped at its short lifespan. Pilots kept flying desperate missions, knowing the war was lost. Every sortie was a miracle, every failure a reminder of what might have been. On May 7, 1945, Germany surrendered. France and his surviving team were captured. The Allies wanted to know how they had done the impossible. The irony was cruel. Just as he'd solved the reliability problem, the war ended. After the war, France was brought to America under Operation Paperclip. He designed the T-53 and T-55 helicopter engines at Lycoming, powering the famous Huey. Every jet engine today owes something to his work on the Jumo 004. Axial compressors, air-cooled turbines, simplified manufacturing. But Franz never forgot the cost. "We built knowing they would fail," he said later. "Young men died because we couldn't make them better." That stays with you. Georg Peter Eder lived to see jets become safe and common. "Flying the first jets," he said, "was like riding a rocket that could explode at any second. The women who built the engines returned to normal lives, but they carried the skills and the memory of building the future from scraps." The shocking truth about the Jumo 004 isn't that it was unreliable. The shocking truth is that it existed at all. Franz Shaw died in April 1945 when his Me-262 hit a bomb crater on landing. Walter Novotny died months earlier when his engine failed in combat. Their sacrifices weren't meaningless. Every flight proved jets were possible. Every failure taught lessons for the next generation. The Jumo 004 wasn't the engine Germany needed to win the war, but it was the engine humanity needed to reach for the stars. Dr. Franz and his team didn't just build an engine. They built proof that the future is possible, even when the present says it's not. Sometimes 25 hours of a miracle is enough to change the world. Behind every great leap forward are ordinary people doing extraordinary things under impossible circumstances. The jet age didn't start with perfect materials or endless budgets. It started with engineers, brave pilots, and factory workers who refused to quit. Their legacy flies above us still. Until next time, watch out for more videos